Okay, so this is 2, this is solving two-step equation. So this would be like, you know, if you took a present, maybe it was an article of clothing, you wrapped it in tissue paper, and then you just put it in the box. Okay, just those little foldable white boxes, and then that was it. That was all the wrapping. That's probably how I would wrap it. I would actually probably throw it in the bag. It would be easier, but anyways. So if it was tissue paper, I might put tissue paper. And then put it in a bag. So there's two operations. You gotta pull it out of the bag, or pull it out of the box, and then unwrap the tissue paper. So there's two of them. On most of them, you're going to do the addition or subtraction first, on most of them. You could do the multiplication or division first, but because of a property called the distributive property, you would have to do the multiplication or division to each and every term in there. And you don't want to do that. So usually it's addition or subtraction, unless it's a problem that involves, it's just one fraction on the one side of the equation. I'll show you what that looks like. Then it's better to actually multiply each side first. Deductive reasoning. This will relate here later on. It's the process of reasoning logically from given statements to a conclusion. It's everybody's favorite part of geometry. It's called proof. If I were to give a one-word definition of deductive reasoning, it would just be proof. Sorry, you've already started writing this, but if you want, you can just write proof. P-R-O-O-F, proof. How to get it. Reasoning logically from given statements to a conclusion. You get to do a bunch of that in your first semester of geometry. It's something to look forward to. All my geometry students love proof. That was their favorite. Not really. So the process of reasoning logically from given statements to a conclusion. We're going to do some deductive reasoning at the very end of this lesson, where we're going to go through and pick apart the two-step equation and write the reason behind each of the steps we do. Two-step equations. To undo two-step equations, use multiple inverse operations, working backwards through the order of operations. I'll show you what I mean by that. Start here as you're finishing writing. I might just show you an example of this just with the first one. I'll show you how this works. I'm going to use the wrapping a present metaphor. I'm going to use that on this equation. Here we go. So pretend here on this first one, solving a two-step equation, pretend x is like the gift. That's the gift, right? And then we, what do we do first to x over here? Like if x were the gift, yeah, we do first. So right here we have x right here, right? According to the order of operations, what are we doing first to x if we were to say, yeah. Okay, that's what we're going to, that's the inverse operation we're going to do, is divide it by 2. But not just solve it, let's just build, it's like we're wrapping the present up first, if you will. So the inverse of dividing would be, so we're multiplying x by 2, right? Let me write that down. So this just says, first step is multiply x by 2, and that's like wrapping the present in the tissue paper. Then what do we do next to the x? That'll be the inverse operation. That's how we'll undo it. What are we doing to it in terms of in the actual equation? We're adding 3. And then we get 15, right? So it's like building the equation. So if I want to, let's do this here. If I want to work backwards, here's what I'm going to do. I'm going to take 15. Let's see if this 15 will stay all together. Take 15 over here. I can't go, if I'm unwrapping the present, right, I have to go in reverse order, right? So if I start with 15, what's the inverse operation of adding 3? Subtract 3. So what I'd have to do to the 15 is subtract 3. You got a number in your mind? Take 15, subtract 3. 12. You got it? Okay, then what do you do next? So we've lifted this off, right? It's gone. It's out of here. I can't get it completely out of here, but there it is. What do I do next to get x all by itself? So I pull the tissue paper off. Yeah. Now, divide by 2. So the inverse operation of multiplying x by 2 is to divide by 2. So that's what I do next, is divide by 2. So did you have that number in your mind? 15 subtract 3 is 12, divide by 2. That's what you get. That's what the answer is. Okay? It's 6. We just did it in our heads, right? All we did is we started with the 15, which was the answer, and we worked backwards. We subtracted 3. It's like we lifted off the 3. See you later, right? And got to 12, and then we lifted off the 2 by dividing to take 12, divide by 2, and get 6. So you can do at least 2-steppers. Okay, I don't know beyond that, but at least 2-steppers. We could probably do it mentally, maybe even a 3-stepper. Okay, we could do it mentally. So that's the process we're going through. So, and later on, this is called deductive reasoning. Later on, we're going to write down the reasons here. So just keeping that in mind, subtract 3 from each side. So that's what we did first, right? Subtract 3. So we have 2x equals 12. And then the next step was divide by 2. So take 2x divided by 2, take 12, divide it by 2, and we get x equals 6. Which is exactly what we got when we did it mentally over here, starting with 15, subtracting 3, and dividing by 2. It says don't forget to check your answer. That's probably good advice. Mentally, you could do this mentally, I think, still, but here's what the check looks like. The question is, does that left side equal the right? 2 times 6 is 12, plus 3 more is 15, so yes. Probably do that mentally here. Try this one right here. Go ahead and try that right now. And I'm going to just pause the video here. Okay, so you should get z equals 16 on that one. All right, using an equation as a model, you're making a bulletin board to advertise community service opportunities. You plan to use half a sheet of paper for each ad. You also need 5 sheets of paper for a title banner. You have 18 sheets of paper total. So how many ads can you create? So we need to label a variable. You could use X each time. You could use, what are we actually finding? Sheets or ads, I think it is. How many ads we can get is what we ultimately. So you could use A for ads. I shy away from A because it looks like a 9. All right, so A is not the best letter, but I might just use X in this case anyways. So we're going to say X equals number of ads. See, this is one I think some of you could probably solve this just by thinking about it. It's probably a possibility. Like the word problems from the other day, a lot of you could. But we're going to write an equation to solve this. So we have 18 sheets of paper total. So how many ads can you create? So we've got, the equation comes from this part right here, half of a sheet of paper for each ad. And here, you need 5 sheets of paper for the banner. So you're going to give up 5 pieces of paper, completely lose them just for the banner. Okay. So half a sheet of paper for each ad. So it would be 1/2 of x, so half a sheet of paper for each ad, plus the 5 sheets of paper you need for a title banner. So all this takes care of the two-step equation part, and that gives me a total of 18. So the total is going to go right here. The total will go right there. And then it's just like the problem you just did. It is in 2 steps. So the first step would be subtract 5 from each side. So I have 1/2 x equals 13. And then final step would be take the 1/2 x, put parentheses around it, multiply it by 2. Take the 13, parentheses around it, also multiply it by 2. And 1/2 and 2 cancel out to equal 1. So I have x equals 26. So that would be 26 ads. So it's right up here. So 26 ads. So that's a 2-step equation that we wrote. Perhaps one that you could do without ever writing an equation, I would agree. Just take the 5 sheets that you need for the banner out of there, and then double what's left over, because you get 2 ads per piece of paper, so you could probably do it. But they're building in complexity, so there is a point to writing the equations to make it easier. And then you can change it up, too. Once you get a variable in there, you can change it up. What if we change the equation up a little bit here and say 1/4 of a sheet for an ad? What would change in this equation? The 1/2 would change to 1/4. So you have 1/4 x plus 5 equals 18. Go ahead and solve that and tell me how many ads you could get out of that. So yeah, you should get x equals 52 on the U-try one. All right. All right, this is the one problem where it's actually better to multiply each side first. This is a fractional equation. It's a single fraction on the left. You don't want to just add 7. That won't actually cancel out the way that you want it to. If you added 7/3 to it, you could. But just adding 7 to the top of this is not doing what you think it's doing. You can't just add 7 here and then 7 over here. Well, you can, but you're adding 7 to the entire fraction. And so you would have to get a common denominator and so forth before you can even combine them. And it won't cancel out like you think it will. So when you see a fraction of this form, just one single fraction, I think the easiest way to handle these is to take the x minus 7/3, place it in parentheses, do the same thing with the other side, and multiply each side by the 3. Okay, so multiply by the 3. It's kind of like if we were going through our present wrapping thing here. If x is the present, what do I do on the left side to x first here? What do I do first to x if you follow the order of operations? It's not divide by 3, right? I'm subtracting 7 first, then dividing by 3. Do you see that? I'm subtracting 7 first, then dividing by 3. So if I want to reverse that process, what do I actually need to do first? Write it down. I said I'm taking x, I'm subtracting 7, so minus 7, and then I'm dividing by 3. So if I want to cancel this out, what do I have to do first? Multiply by 3. You see that? And if I want to cancel this out, I do add 7 next. So do you see why I'm multiplying by 3 first and not adding 7 first? A lot of students don't see that, but that's why. It's not going to work like you think it should. Add 7 first. Okay. So multiply by 3 first. This cancels out. We've got x minus 7 equals negative 36. And these are hard problems, even for students who are in the higher level of algebra 2. One more step here. Multiply by 3, then So we did the multiply by 3 first, then we're going to add 7, so add 7 to each side. So x equals negative 29. So I'd like you to try the next one on. Alright, so you try one, should be x equals 26. I think I was able to check everybody's. X equals 26. You multiply by 4, and then you add 2. So really powerful. If you could do this in your head, if you're at a point like, for me as a teacher, for a more advanced algebra student, do that in your head almost. I mean, I want you to show your work to make it, so you've got it down, but it's really just multiply by 4. Okay, got it. 24 in my head, right? Add 2. 2 more to 24 is 26. So it could be done. These two steppers. All right, so now we're getting a full circle back to the, what is that, deductive reasoning. I said deductive reasoning was proof. So we're going to do an algebraic proof. We're going to prove whatever the answer is to this equation. It only has one unique one. So here I have negative x plus 8 equals 3. If I want to get negative x by itself, I've got to subtract 8 from each side, right? So we have, let's just do this. I'm going to do minus 8, so I have negative x equals negative 5. And straight across from the result of subtracting 8 from each side, we're going to write the reason. And the reason is simply this. It's called the subtraction property of equality. Okay? Because we're subtracting the same thing from each side of the equation, keeping an equivalent equation. So it's subtraction property. And if you just put that, we'll assume of equality, because whatever you subtract from one side, you have to do to the other in order to keep the equation equal. So we'll call it the subtraction property. It's really the subtraction property of equality. And if you want to abbreviate it, you could. You could abbreviate prop and subtraction probably. And then one more step. See, we have a negative x here. That's not going to work. We want positive 1x. What do you have to divide each side by or multiply each side by to get a positive one? Negative, yeah. So negative 1. So I'm going to take negative x, divide it by negative 1. I'm going to take negative 5, divide it by negative 1. So x equals positive 5. And the second reason on there is called the, well, the way I set it up, I did division property of equality. Could you have done multiplication property of equality? Yes, you could have, okay? You could have multiplied each side by negative 1, but we'll call this division property because I divided by negative 1. See if you can solve the problem and then write the two reasons, just two reasons. What are the properties? Really, you're just telling me what operation you're doing at each step. That's all you're doing. You have 4 choices of operations, right? Addition, subtraction, multiplication, or division. So go ahead and try that. So we have the first step is addition property, adding 5 to each side, and the second step is multiplication property, multiplying each side by 3.